Hi friends, welcome back to my channel. I'm Ahammed Shafvan. Today I am going to explain you about foundation design by using of safe software. Yeah, the problem is also given that there's total C1, C2, C3, C4 like C16 columns with different measurements. The spacing between two columns is 6 meter and safe bearing capacity is 300 kilonewton per meter square. Allowable settlement is equal to 1 centimeter and the all loads are already given. Okay, let's start. First we select file, new model. Yeah, then design code as IS 456 2000. Design preferences modify your bar short and its change as clear cover top and bottom as 15 millimeter and the preferred bar size is 20 and click OK. Then it make it as unit size equal to metric and it's all OK. Then grid only select. Then we know that it's 6 by 6 foundation. So 6 into 6 means 18. So 18 plus 1 19. Select it as 19 x direction and y direction, and x direction spacing is 1 meter and y direction spacing is 1 meter. Okay, then it's all defined. Then we have to define the materials. So click define materials. Then add new material. Then click we given that M40 concrete. New material name is M40 and material type is concrete. And this weight per unit volume is 25 and its modulus of elasticity is something around 31277.4. It's got by I score. Then coefficient of thermal expansion, that's 0.000055 and its FCK value means actually compressive strength as 14 Newton per millimeter square. Click OK. Then add new materials as rebar. Rebar is HYSD 500 that's given in the program. The type is rebar. Then weight per unit weight is 77 kilonewton per meter cube, and the modulus of elasticity is 2. Okay. Then minimum yield strength is 500 and max minimum tensile strength is 545 Newton per millimeter square. Click OK. Click OK. Then define the properties of slab. Slab properties. Define slab properties. Add new property and rename it the property name as matte footing. And the slab material is M40 concrete and make approximately 500 thickness of slab, and the type of slab is matte. So take the slab, select it as matte. Click OK. Click OK. Then define next material. That next material is something like column properties. Just given two type of problems, that's 500 bar 500 or 600 bar 600. In the middle four columns are 600 bar 600 and all else columns are 500 bar 500. So add new property of column. First see 500 bar 500. The material is M40 and value x axis 500, y axis also 500. Okay, click OK. Then add another new property, that's column 600 bar 600. M40 concrete 600 bar 600. Click OK. Click OK. Then define the load, that's load patterns, and make sure that dead load and live load is already given. Then click OK. Then define and load cases. OK. define load combination, that's add combo, and the first combo should be live load and load with a scale factor of 1.5 and its strength is ultimate. Add another new combo, that's combo 2. Its combo 2 is live load and live load of the scale factor is 1 and service normal, service initial and long time. OK, click OK. Then we have to design the soils upgrade properties. Let's click the soils upgrade properties and modify this one. And we know that by the calculation of upgrade modulus, that's it's busy by allowable. That's we by the calculation we got that 3 into 10 raised to 4, that's 3 e plus 4 kilonewton per meter cube. Click OK, click OK. And the old materials and everything is defined. Then we have to draw. So firstly we need to draw the slabs. Click draw slabs. Just click the first point. Then after 18 meter, click the point. 18 meter, click the point. Click the point and place the normal first point. And it's the slab. Press escape. Select this slab by clicking here. One areas of all these are selected. Click on edit areas and spread, expand or shrink areas, and it will expand offset value like 2 meter, that's 2000 millimeter. Click OK and it's all done. Okay, then we have to draw column. Let's draw columns, and firstly we define that property below is none and property above is 500, because we have to draw for the property is above, so height is also below is 0 and it is above is 2. And click on the first point to 1 difference. After that 6 meter, click again another one point, again 6 meter, another one point, again 6 meter, another one point, and 6 meter, another one point, like that. Okay, then select next, we will see that that's C600 and click on so fine. Next we have to assign that this slab property as soil, so click on this slab and assign support data and soil properties, that's soil 1. Click on OK. That will define that soil 1. Then we have to draw all the strips, design strips. Then click on design strips, and we by the calculation we got that the strip value is 4, because 1.5 into least difference, that's 6, and then the value is 4. Okay, click on the edge point. After that, select every strips and change the material as rebar material is HYSG 500 everywhere. Yeah, it's already defined. Then we need to apply the loads on every columns. That's already given that dead load and live load. So select every columns by clicking left button and assign load data point loads and dead loading C1, that is given that 1850 kilonewton and x direction dimension is 500, direction dimension is 500. Click OK. Again select by for the simplification by clicking select get previous selection, assign load data point loads and change it as live load. Live load is given that 797.6 kilonewton. Click OK. Like that do every columns. I will do I am skipping this part because the lengthening of video. Yeah, here all the point loads are defined, applied. Then we need to run the analysis. For that run analysis, I'm saving this project as in the folder project, the name of project, save. This should take some time because it's analyzing and the analysis view. For that here we can define by this shade colors. Then we need to run analysis and design. Okay, and we need to display show punching shear design. Here some values like here all has above 1. It should be less than 1. The punching ratio should be less than 1, then only the design is success. So we need to change the thickness of slab. For that we unlock this model, again define design, modify and change it as 1000 millimeter thickness. Click OK and click run analysis and design. Then click display and show punching shear design. Here is also some values, only these core values are more than 1, so we again need to unlock and to increase the slab properties and slab thickness is something like 1200 millimeter. Click OK. Again run analysis and design. Click on display and show the punching value, and here's OK, all the values are less than 1. Then our model is perfect. So for that if we need to show the bending moment diagram, shear force diagram, so I get by clicking display, show strip forces and upload here bending moment. Apply. Here's the bending moment values in the layer B. Apply. Shear force y direction values. We want to shear force diagram here. Here's the shear force diagram values. So we have this the shear force values like that. And if we want to see the extrude view, click on extrude view, click OK, and 3D model. This is the extrude view. Yeah, okay. Then we need to, if we want to show the crack with this, click on crack with this and click on apply the crack slab crack well. Okay, pause. And we need to run detailing. Click on all three parts and use the detailing by clicking this drawing components and views and slab or mat component slab views and a rebar table. We get that rebar values, all the rebar values. Framing plan, we get the plan of framing. Rebar schedule, we get the schedule of rebar details. Everything is bill of quantities is the quantities of rebars. Slabs, we given individual slabs. Here we also show that plan of rebar plan, top rebar plan, bottom rebar plan. Okay, extra everything will get by clicking here. Okay, this side, and that's not the problem.